Right, I think I've got it this time. Okay, you've got a polymerization reaction. You've got to join those molecules together, head to tail, so that you get your polymer. Now, the easiest way of doing that is to take one of those units, and you know the moment you're dealing with alkenes, it's addition, and you know that that double bond is going to go, it's going to disappear. So what you do is, you take that monomer unit and you stick on there, whatever it is that's part of the molecule at that stage. And the double bond is gone. The double bond gets broken and it becomes part of the polymerization process. So generally speaking, you need to take 3 of those, and once you've done that, now the reason why I suggest you set it out like this is that you're less likely to make mistakes with the structure of the monomer. So you join those up like that. Alright, that's what it should look like. How many of you got that correct?
Yeah.
Anyone got that wrong?
If I put a hydrogen to the end of my carbons, is that class as wrong?
If you put what?
If I put hydrogen to the end of my carbon.
If you've got, hold on, that raises it, please. The question is, if there's a hydrogen at the end there, is it wrong? Yes, it is. Because you've immediately indicated that that chain does not carry on beyond those 3 units. You have to indicate that that chain carries on. So that's the first one out the road. Easy. Next one.
Wait, Josh, shut up.
Again, when you hit a question with the double bond in it, you know that it's going to be an addition reaction. And this is how I would recommend that you go about answering this one. You can get confused, unless they give you the full structural formula, you can get confused by what's there. So the easiest way to get the correct answer is to take that starting material and copy it out exactly as it was written. So it's CH3, C, we've got a methyl group tacked on there, but that doesn't matter too much if you don't fully appreciate that at this stage. But this bit here, where the double bond is, that's the bit that's going to change. Nothing else happens. So we can put that in. There's our single bond from the double bond, and then we've got CH2. And then all we have to do now is add on what's left. Now, the addition reaction here involves a hydrogen molecule. That's going to split. One hydrogen is going to go on one side, one hydrogen is going to go on the other. Now, it looks a little bit messy, but it doesn't matter. If you just stick the hydrogen up there like that, and the other hydrogen up there like that, as long as you've copied the rest of that molecule down properly, that's it. If you feel comfortable, you can expand the whole thing and do the full structural formula bit. But the problem with that is, if you make a mistake, you've got it wrong. Whereas if you take that molecule as it's written, take the double bond out, and then split this molecule, you'll get the answer. You okay with that?
Yeah.
That's how you go about constructing answers to questions involving addition. This one is an oddity. It's an oxidation reaction. It's oxidation of the double bond. All the other reactions of the double bond simply involve addition reactions. This one's oxidation, and so it's just a one-off. You have to remember it. But again, you copy it down exactly as it's written. CH3, CH2, dead easy so far, CH. That double bond is gone, and then we've got CH2. And then you just simply need to remember that acidified permanganate oxidizes double bond, and you get the two alcohol groups. Alright, you okay with that? You should by now recognize that one without any difficulty whatsoever. Double bond. Again, it's an addition reaction. And the way to make sure you get that addition reaction correct is to take this molecule here, copy it out without mistake, CH2, another one in here, CH. This is the only bit that's going to change. We've got that double bond in there. It's only going to be a single bond now. CH2. It doesn't matter if it looks a bit messy as long as everything's there. Now the conditions here can be given in different ways. What you have to spot with an alkene and its addition reaction, you have to spot the molecule that's taking part in the addition. In this case here, it's a water molecule. Don't be confused. Sometimes it says H plus H2O. Sometimes it's got phosphoric acid in there as a catalyst. But in this case, it's H plus H2O. That's the only thing that can be doing the addition. So we split that up, and it's a major product. What's the rule for the major product? Shadi? Rich getting richer. So which side is it going to go on there?
On that side.
So the H goes on there,
Where there's more hydrogen.
and the OH goes on there. Excellent. I think you've got that. Hopefully. Oh look, another addition reaction. I'm just giving you plenty of practice at addition reactions. And we won't waste time on this. CH2, there's a double bond. It's only a single bond now because a double bond goes when that reacts. It's HCl. One bit goes on one side, the other bit goes on the other, and it doesn't matter. Now notice, if you set about answering the question like that, take that molecule as it is, copy it out, and then just remove the double bond. You don't need to worry about ensuring that the carbons have got 4 bonds in them. Right? You won't make a mistake as long as you copy it out exactly as it is.